Hello again, so continuing where we left off a while ago, so now let us specify the directions of your vectors. So let's say that this is now to be your vector A, this is now to be your vector B, this is now to be your vector C, and this is now to be your vector D. So how can we name them? So for your vector A, so by the way guys, before proceeding, we actually have two methods. So for method number one, so I would just be writing a line here. So let's say that this is now to be your method number one for a moment. So method one, and we also have our method two. Okay, so for your method one, so what we would be doing here is that of course we would now be writing the magnitude, and as for its direction, we would now be making use of our 0-degree reference line. So that is for your method 1. So once again, for your method 1, we would be making use of the 0-degree reference line. And as for your method 2, we would now be using our geographic directions, such as our north, east, west, and south. Okay, so there. So for our vector A, this is now to be A. Then for me to emphasize that this is to be a vector, I would now be writing an arrow here. So A arrow, so this signifies that this is to be a vector, so equal sign. So write the magnitude first. So the magnitude of this line is to be 76 newtons. So 76 newtons. So once again, if you would be writing it this way, this is just to be a scalar quantity. And for you to write this as a vector, we must of course write the direction here. So once again, for your method number 1, we would be making use of the 0-degree reference line. So the angle that you will be writing here is to be the angle from the 0-degree reference line up until the vector. So it is already indicated here that this is now to be 45 degrees. So 76 newtons, 45 degrees. So this is now to be our answer. So what about for vector B? So for vector B, so B, we would be writing an arrow sign on top. Then this is now to be equal to, so what is to be the magnitude? And that is now to be equal to 53 newtons. And what is now to be the angle? So it is indicated here that this is now to be 20 degrees. However, using method 1, we would be measuring from the 0-degree reference line, which is the east line. Okay, so we would now be measuring from here up until this point. So if this is now to be 90 degrees, and this is now to be 20 degrees, so 90 plus 20, so looking at the calculator to your left, so 90 plus 20, so that is now to be 110 degrees. So with that, this is now to be 110 degrees. Okay, so what about for the other two? So I would just be deleting this for me to have space. So for the other two, so for 93 and 88 here, so for your vector C, this is now to be equal to, so 88 newtons, so this is now to be its magnitude. And as for the direction, so if this is now to be 90, and this is now to be 180, so this is now to be 180 plus 15. So once again, just measure the angle from the origin or the 0-degree reference line up until the vector in a counterclockwise direction. Okay, so once again, looking at the calculator to your left, so that is now to be equal to 180. So this is now measured from this reference point up until this, and we would now be adding 15 degrees. So with that, plus 15. So our answer here is now to be equal to 195 degrees. And as for D, so it will be up to you on how you will be solving it. And in my case, I would just be measuring from this point up until this point. So that is now to be 270 degrees plus 85 degrees. So with that, so 270 plus 85. So easy peasy lemon squeezy. So this is now to be 93 newtons, 355 degrees. So this is to be for your method 1. And for your method 2, we would now be making use of the geographical directions. So north, east, west, and south. Okay, so for this one, so for the first a vector. So for vector letter A. So for a moment. Okay, so for vector letter A, so once again, just write the magnitude, which is 76 newtons, and followed by the direction. So we have two ways actually. So we can either write it like this, so 76 newtons, then followed by so 45 degrees. So 45 degrees. So what is that? So 45 degrees north of east. So this is to be your north, this is to be your east, this is to be your south, and this is to be your west. So that is now to be 45 degrees north of east. So you can write it this way, or you can also write it this way. So 76 newtons east. So east 45 degrees north. So do not get confused here, guys. So this is the same as this. So if you would be writing it this way, so north of east, so this is actually wrong. So it should be the other way around. So for this one, so I will just be writing here 45 degrees north of east. So take note, north of east. So what that means is that from east, you would be going north. So that is it. Okay, so what about for this B? So we actually have two answers here. So for your vector B, this is to be equal to, so 53 newtons. Then as you can see, this is now to be 20 degrees. So with that, 20 degrees. So coming from the north, you would now be going towards the west. So, west of north. So that is actually, that is now to be your answer here. Okay, so I will just be erasing this. So since you already know method 1, and I will be placing it here. Okay, so another answer for your B. So for your vector B, this is also equal to 53 newtons. So what if my reference line is to be the west line? So I want it to be north of west, just for pretend. So since this is now to be 90 degrees, and this is now to be 20 degrees, so their difference is now to be equal to 70 degrees. So 70 degrees. So this is now to be 70 degrees north of west. So basically, both of these are the same. Okay, so once again, take note, guys, that if you would be making use of this nomenclature, it is to be different with this format. Teka, erase lang natin para hindi kayo malito, since I think you're already confused. Okay, so once again, this is not equal to 53 newtons west, 20 degrees north. So this is not the same, guys. Because if you would be making use of this, from west, you would now be going 20 degrees north. So west, 20 degrees north. Okay, so from that, if you would be drawing that vector, you must now go from west going towards the north. So what I mean here is that you would now be measuring 20 degrees from west. So once again, 20 degrees from west going towards the north. So from west going towards north, that is now to be 20 degrees. So yun, using that nomenclature, this is now to be your vector, which is not this one. So it is actually erroneous. Okay, so emphasis, guys. So ito, west of north. So in Tagalog, west ng north. So manggagaling ka ng north dito, pupunta ka ngayon ng west. But if this is now to be your format, whereas this is now to be W, then followed by the angle, then followed by the second direction. So from W, so it means that from west, you would now be going 20 degrees going towards the north. So from west, you would now be measuring 20 degrees towards the north. So this is now to be 20 degrees. That is if you are using this. But if you are using this, west of north, for a moment. So paki-replay na lang kung medyo nalilito kayo. So dito, so you would now be starting from north. Kasi sabi niya dito, west of north. So from north, you would now be going towards the west. So do not get confused there. And if you get confused, please replay the video before proceeding. Okay, so with that, so this is now to be our answer here. And for our vector letter C, so vector letter C. Oops, sorry. So vector letter C. So this is now to be equal to, so if I am to make use of this 15 degrees here, so 88 newtons, 15 degrees south of west. So south of west. Or you can also write it like this. So 88 newtons from west, 15 degrees going towards the south. So W 15 degrees south. So both of these are actually the same and they are equivalent. Though if you can notice baliktad, no? So S of W and here W angle S. Okay, so do not get confused there. And if you want this to be your reference angle, instead of this one here, you can do that actually. So with that, if this is now to be 90 degrees, it means that this is now to be, oops, sorry, this is now to be 75 degrees, if I'm not mistaken. So, para hindi mapahiya, looking at the calculator, 90 minus 15, so that is now to be 75. So, tama. So, 75, and if you want this to be your basis, this is now to be equal to, so 88 newtons, 75 degrees west of south. So, W of S, or 88 newtons from south. So south, then 75 degrees west. So all of these are correct. So it would depend upon your decision, which of the following do you prefer. Okay, so I will just be erasing this for me to have space for vector D. So for vector D, this is to be equal to 93 newtons, and it is now to be 85 degrees. So 85 degrees. And from south, you would be going east. So with that, east of south. Or you can also write it like this. So 93 newtons, 85 degrees. I'm sorry. South, 85 degrees east. Okay, so from south, you would now be going 85 degrees going towards the east. Okay, so there. Okay, so proceeding, let us now discuss this collinear vector, coplanar vector, and concurrent vector. Okay, so when we say collinear vector, so these are to be the vectors that lie along the same line. Okay, so let's say that this is to be your imaginary line. Okay, so if that is now to be your imaginary line, and let's say you have a vector A, so let's say that this is now to be your vector A. And let's say that this is now to be your vector B. So as you can see, they lie along the same line, thus they are collinear. So this is to be your vector A, and this is now to be your vector B. So with that, our conclusion here is that our vector A and vector B are collinear. Okay, so what if? So what if that their directions are opposite? So let's say that this is now to be opposite. So with such guys, it is still collinear. It is just that they are opposite in nature. Okay, so there. So what about for coplanar vectors? So for your coplanar vectors, these are to be your vectors which share the same plane. So by the way, so when you say collinear, they share the same line. For coplanar, these are to be your vectors that share the same plane. So with such, so let us draw another imaginary plane here. So let's say that this is now to be your plane. Okay, So for example, that in that plane, we would be having multiple vectors. So let's say that this is now to be your vector A. And as you can see, this is now to be your vector B. This is now to be your vector C. And this is now to be your vector, let's say, D. Okay, so as you can see, all of these lines here have different slopes, so they are not parallel to each other and they do not share the same line. Thus, they are not collinear. But they are coplanar because they share the same plane. So they are actually in this plane. So for example, that this is now to be your x-axis and this is now to be your y-axis. So they share the same plane xy. Thus, they are coplanar. Oh, by the way, guys, here in collinear vector, so we can actually call this as collinear parallel. So collinear parallel lines. So with such, guys, if let's say that you would now be moving this line here to this point, but they are still parallel, for example. So when we say parallel, they share the same slope. So if they are parallel to each other, they are still considered as collinear parallel lines. But for you not to get confused, para talagang sinusunod natin yung definition niya, pag sinabi natin collinear, they share the same line. Pero yun nga lang, in terms of physics, kino-consider, so they are actually considering parallel lines as collinear lines. Even though they do not have collinear points. So, medyo pag-isipan nyo yung mabuti at medyo nakalito. Okay, anyway, so that is for collinear and coplanar vectors. So what about for concurrent vectors? So for concurrent vectors, these are to be vectors that share the same point, regardless if it is collinear, coplanar, or not. So for example, that we would be having another, vectors here. So let's say that this is now to be our vector A. Then we have another vector here. So let's say that this is to be your vector. Let's say that this is to be another vector. Let's say that this is to be another vector. So as you can see, all of these vectors share the same point. So as you can see, they share the same point, and thus it is now to be concurrent. Okay, so regardless, once again, regardless if it is to be coplanar or not, so let's say that they belong to different planes, but if they share the same point, they are still concurrent. And as you can see here, so by my drawing, by the looks of it, I think this red vector here is to be collinear with this vector here. So with such, these vectors here, the red and the green, are considered collinear concurrent vectors. So assuming that they lie on the same plane, they are collinear coplanar concurrent vectors. So this one here. So for example, that this vector here and this vector here, share the same plane, they are to be concurrent coplanar. So ayun. So just remember this, guys, that if when you say collinear parallel, they are to be, they share the same line or they share the same slope. And for your coplanar, they share the same plane, so co-plane. And here, when you say concurrent, they share the same point, so concurrent, so same point. Okay, so that's just about it.